All right, guys, so we are going to start talking about some more with linear equations in real-life situations and their key functions. Remember, a linear equation is y equals mx plus b. So this talks about Travis Smith and his brother Roy are co-owners of a trucking company. One of their regular weekly jobs is to transport fruit grown in Pecos, which is south, to Dallas, which is north, to the distributing plant. He knows his customers are concerned about the speed with which the brothers can deliver the produce because fruit will spoil after a certain length of time. Travis wants to address his customers' concerns with facts and figures. He knows a typical trip between Dallas and Pecos is 7.5 hours, so he makes this graph. What information can we look at the graph? We have the x-intercept, which is 7.5 hours. That's how long it took him to get there. We have the y-intercept, which is 450. It means that Pecos is 450 miles from Dallas. We can also count the slope. So notice the scale is by 45. So 90 and 90 is 180 for 3 hours. So we're going 60 miles an hour. B says, locate 3270 and put an A there and describe the information. Well, 3270 means, if we look at our labels, after driving 3 hours from Pecos, we are 270 miles from Dallas. According to the graph, how many hours will it take Travis to reach Dallas from Pecos? Well, again, that is our x-intercept. So 7.5 hours, 0 miles to Dallas. Interstate 20 is a direct route between Pecos and Dallas. Based upon this graph, what is the average speed? At what average speed does Travis expect to travel? Explain how you determined your answer. So again, speed is your slope, which is rise over run, and we had 180 miles closer to Dallas every 3 hours, so that means we are going 60 miles closer to Dallas every 1 hour. So we can use this information to complete our table. We have our y-intercept 450. They're using h and d, but remember we can use x and y and then replace with h and d if we are uncomfortable with that. If our slope is 60 miles closer every 1 hour, so we can just keep subtracting 60, so 450, 390, 330, 270, 210, 150, 90, that's a 0, and 30. We can take this information and then write our equation. So I pulled this from my previous page. You can see it on yours. It says, write an equation to express Travis's distance, d, from Dallas as a function of the number of hours, h. So remember, function means we can put depends there. Y depends on x. So d of h, distance is a function of hours, is equal to 450, my y-intercept, minus 60 times the number of hours, because we are getting closer. And that's what this is talking about. This is talking about our graph is negative, so our slope should be negative. If we have the point 690, does it fall on our graph? Well, we can plug in 6 for h and d, 90 for d. 60 times 6 is 360. Take that from 450. Yes, it does work. We can come up with 4 more ordered pairs. So if we plug in 1, 5, 8, and 10. For h, you can see my work over here on the side. I get 1, 390, 5, 150, 8, negative 30, and 10, negative 150. Well, the first 2 are the only ones that make any sense. The second 2 don't make sense because if we have a negative distance, that means that he drove past Dallas, which means his food's going to spoil. Reasonable domain and range. So if you go back to your table, or even to your graph, we can see that x, our lowest x was 0. That was when we started. And our highest was 7.5 hours. So 0 is less than or equal to h is less than or equal to 750. Distance from Dallas, 0 means we are there. We started in Pecos at 450. So 0 is less than or equal to d is less than or equal to 450. Use the graph to identify the 0 of the function. 0 just means the x-intercept. And again, it was 7.5 hours, 0 miles from Dallas. What I'd like you to try tonight is I would like you to try 5, 6, and 7. You can simply make a table over here on the margin where you have, again, it's giving you H and it's giving you gallons. You could use G. And create a table. Notice the scale is by 2s. So make your table accordingly. Use the graph to identify the zero of the function. And we're going to look at that tomorrow.